Okay, fine. Okay, fine. Good evening, everyone. So, class to over see. Koi can kedoba. Rotational motion to manebo ka. Adun rotational motion to mani. So, koi nangrang na give do motion si makalani lay translational motion habama, rotational motion habama. Translational motion dana change in position lay rotational motion dadi change in position natte about a fixed axis mazi rotate to bani the blah blah system of particular center of mass nainagre, then again center of gravity center of mass kai khenai nainagre, then some question kara center of mass ki the based of question solve to gre, motion of center of mass the based of question solve to gre, vector ki the based of question solve to gre, and then kedoba rotational physical quantities ka translational physical quantities ka my counterpart haigadra ka mana budo ka adudu akoina ngarang hypertroph from high grade. So formula cc katanga loy bidin natte formula cc gisi ka angular momentum gi formula z L is equal to I omega na zo high ka aduga atopa torque ki se torque ki formula si akoina I alpha zo high R cross F katang natte ba I alpha or C I ba ana sigi formula sing si phajana khangadabani aduga kamaina kedobai lai no haibna chingbudu su phajan khangadamne ba so adugi ne sir nangrang ka hairam du no da physical class one tawning habado sigi formula sing ji takpa matam da visualize tawba ma hadi thong gumba manaka lepaga kamain tawraga angle z sumain leiba som side ta hadi magi perpendicular oiba oidaba oidragana sumaina keno tawba haita kaine angle z theta ji acute oiba obtuse oiba and then perpendicular oiraga sum yungdaba yungkatpa oiraga nong kai dawduno kai do aduguma ma'am amadu ai noida takti takning bane so ai chok ma ngambreng ge ko diagram yega ado sigi kedoba keno singje analog singje khangadabane ba analog se ko noina ai petum chok noina hena khangamani biology da analogous organ homologous organ and high analogous organs in a same function labor different origin labor. For example, sekti gi masaga, uchi ki masaga is analogous organ because fly to this is name, but they have different origin. Aduga homologous organ has same origin and different function. So again, sekti masaga, atopa mammal gi masaga hagadi, they have the same origin by 4 limbs ngatani, but sekti di pai with the sinai atayina sat with the sinai or uka the sinai natra. So something like that. Adu do no linum khang manatra analogous organ have the analog have the analog have the manava have a ana rotational motion ga translational motion ga ji kaine for example no inaga kitang nungai language da gana kaino do haitare no kaino khang ra no spider-man gi multiverse to wodo kari spider-man ji kaino suidana ka 1 2 3 subra spider-man ahum subra Peter Parker lere dagi kariba ani atupa ani yem lai dana ai maming gadi khangdre Ellen habra very Ellen habra do amana kari Hardy habra kain hongde youngest to kitang ado anyway ado aina mai multiverse ki type tane aduna motion ji da translational universe ama laiba rotational universe am laiba adu type tane ko aduna kaido we have matam da ngasai gi translational universe haigadra asida laiba mass se asomdana moment of inertia ka weba mass ka moment of inertia chap manaiba roles habdi mass auragadi aina race tagi motion da purakpa da wagani ko and then magi uniform velocity do aina accelerate or decelerate over the wagani sumain to dana rotational motion the moment of inertia auragadi mazi race tagi rotation to the wani and then mazi angular velocity in the accelerate rotate to my angular velocity to increase or decrease to the wani moment of inertia si auragadi aduna mass khatang da depend to deba aduna sir na ngarang no video ma yengan bodo angang macha ani duna swaina chai amada ngasai gi road to gi manak naksal lagadi my axis of rotation do sisina axis higi sida axis of rotation ji sumai lai dune ba sumaina gyan ta so mass ani sida naksal lagadi kaidawni amatam da my distribution of mass axis yam na abni na moino inertia pe pa ba ko ado same mass si swain lap thogadi total mass of the body di chap manai ba mass chap manarga ju moment of inertia manani have laite ba Auna for example akoina spin to matamda or yam live example Shaktiman no ikhang Shaktiman na akoigi India gi superhero mai bido so Shaktiman spin to ma sumain to spin to deba sumain to spin to dra sumain to ga kaina masa tasal la kan da ko so adugi time mo hedi kayane have the pixel lagadi moment of inertia p eba moment of inertia p agadi belai lepan belai yang kadan belai tapthan belai be da rotation da aduga moment of inertia chahol lagadi ke doni one eba da ko so moment of inertia is the inertia to rotational motion mass is inertia to translational motion hagadra ko adumaina uneasy kenab ji khangadabani ko and moment of inertia formula ne mr square le sumai tawdana akoina kaino da haitare ko translational motion the linear displacement laidana ko have distance asuk chatpa or displacement asuk chatpa na ko time asuk chatpa na adugi linear velocity laidine ad rotational motion the man angle asuk move to bana poche exist we akoi bi sum chatpa matam maji ke dor kani have the angle lama subscribe to dina sidagi silem baija sigi angle jina sigi angle my position vector do sigi line jida na aji ano position vector am the change to rani ma shift to bana adugi position vector do sweep to ri ba ke do ba angle do aduduna angular displacement lom the chat hedi angle cam strip to gain my position vector do na ko and all position vectors are kedoba are taken as hedi are kedoba based on the axis haita axis tagi koine low ne position vector yelak pacha atoba jaga de low ya de ko axis axis tagi yekane ba na auna ke do yam matam da magi angle cam sweep to per unit time have the angle yam sweep to ragadi per unit time da di ma si angular velocity yam haine yam thuna ma si rotate to haine ba ko adu minor leituni so that's angular velocity then again from the linear momentum this are already high gram mass into velocity ni ko ana mass manarga su velocity yang buduna momentum chawi for example sir no maru du kapthorak ba khutna thombaga khutna thomandi velocity pick panina momentum pe kapthora ga di yang main momentum wang yang phaudo satkini mi da pala si dine adain to na adagi amaka velocity yang bu chap manarga su mass velocity manarga su mass hour ga di mass hour da momentum hene ba and mass manarga su velocity acho buduna momentum hene hadi mass so depend to velocity da su depend to momentum je hadi for example in a tennis ball amna kanna thombaga nungam na kanna thombaga velocity yang di chap mana dini kanna dum thom dini adu nung ne na ne kai na nung na ma se le kan ta bra aduna velocity yang mana ga su ma sen momentum chawe and that's momentum adu momentum gi formula si kai no translational motion the mass into velocity ne ba adu ga di rotational motion the di momentum ji rotation ke do rotational momentum hai de koina angular momentum hai ko so magi momentum gi formula ji kai na the mass into velocity mass ki mapa kai le dino I le dino moment of inertia and linear velocity mapa kai le dino angular velocity omega le diba aduna ne ba sir na sida ano formula ma na si p I omega na ko linear asisi kai do we have the angular momentum gidi linear momentum ne ko so see this L is kind of this L is angular momentum and this P is linear momentum ne ko so angular momentum sa linear momentum kita ta hai dinu na P is kamai igi P is equal to m v vector e draw mass into velocity vector na adu mass ki mota I lani kaino moment of inertia is scalar ni mass scalar ni and v vector in mota omega vector lani omega is angular velocity ko so sumain la kadeni Prithviraj Gyan Tabra Lakshmi Sinthoi asterisk no lo Gyan Tabra Sarnazik explain to Brida.
Oh, is it?
Okay, fine. Aduga kanuniko asterisk no Kingston ga Nikhil ga yakti kay gina.
So Kingston di magi neto low grahabne.
Okay, library de hamma dum yawa ya thing da Nikhil di perform de. Okay, okay. Yeah, no worries. Adedi we have the force mass into acceleration idana ko. So, sir na have the mass kai ga manai moment of inertia manai ba. And acceleration the linear acceleration la ibu som na angular acceleration la ane ba. Auna force ki mota tok la ni tok si kai ga manani matam da mass ki mota kai do ba moment of inertia I and linear acceleration a gi mota angular acceleration alpha la ane ba. So sumain to orga. So CC yamna manager ni kai ga manager F is equal to ma ga manai ba. Sina kai ga manajai P is equal to mv ga manaiba mv do mass into velocity ko so sumain to duna si formula me amse khang da bani si me amse khang ba adu di लीला जी तंखाय में लोरे है बदी नोई rotational analog मैम जे नोई फजना visualize तो वंगा मने बा दो rotational motion खंगे है गदी translational motion हाना फजना खंग दे याद देव translational motion खंग गदी rotational motion खंग मंगम मोय बको अन for example further नोई ना कइदो या मतम द kinematic equation लई को so v is equal to u plus at n लेब्रा अदाइन तो न s is equal to ut plus half a t square n लेब्रा को and then mathang the v square is equal to u square plus twice as na lay ko so sigi pod me amze ke do ya matam the c rotational motion da su chap chan lay dine ba rotational motion da na ke som do in tham ke ka som side da na translational hai ge ko linear hai re ge translational C is in translational gine ko and som side da na rotational gine now rotational ki b is equal to u plus at ki mota kai lakane have the omega is equal to omega naught plus alpha t lakane and s ki mota theta is equal to omega naught t plus half alpha t square lakane b square ki mota omega square is equal to omega naught square plus twice alpha theta lakane so adun takpadi yung c ki ma'am je c da su kai da even kinematic equation du for rotational motion gi universe ta layeba ko rotational motion da layeba translational motion gi ne ba si sina quantum gi chap mana na mai counterpart ne ba rotational motion da sumai i do ne ba gyan ta right ja una translational motion phajana khang ko mi du di rotational motion khang da lai gi ne ba translational motion phajana khang dra ga di rotational motion ji aduni har ko matam da kar inu gyanam ta roi ba ko aduna si phajana khang ma tung rotational motion am khang ga ni ba ko duain dei and then further kay kena to sige formula kara take ba ko no yemo ba ngasai gi kari v is equal to omega cross r hai ko adu sir no hangbe sir why v is equal to r cross omega di ke do ba yadri no si yad de ba or omega is equal to r cross v di yadabra kainega or omega is equal to v cross r di yadabra or r is equal to v cross omega or r is equal to omega cross v c मैम दी यादब्रा सर कईगिनो ख्वाई मथकी जे खतंग ओइने लौइसी अतै मैम जी हमते यादब्रा नोय हंगबे आइबको सो यादी यादे कइदोबा यादिनो खंगब्रा नोय कइनो तौबा नोय मरक्ता खंगबा यावब्रा हाइरो खंगबा यावरगदि हाइरो कुमक्त्रे कनाम कुमक्त्रे पृथ्वीराज लक्ष्मी खंगब्रा सी मैम जमते यादे सी यादे सीजु यादे सीजु यादे सीजु यादे सीजु यादे ओनली सी खतंग याइबको सो कईनो खंगब्रा खंगदे लक्ष्मी खंगदे हाइबको पृथ्वीराज
खंगदे सर
खंगदे एस्टेरिस खंगब्रा सिंथोय नंग खंगदि चेतैरो खंगी खंगदे हाइबदो एस्टेरिस खंगब्रा
खंगदे सर
खंगदिया ओके कईनो है मतलब ननुई अतै जिदिने डायमेंशनली inconsistent ओइरोय नत्रगना मागी वेक्टर की क्रॉस प्रोडक्ट तो inconsistent ओइरोय को अदुगिने अदुम मैम दो खंगदा हाइदि कईगुम जस्ट इन केस नो फॉर्मूला से कंफ्यूजन लाइने s b equal to omega cross r ra natrana omega equal to r cross v ra kaina or b equal to r cross omega ra masi ai khar chamam nare kai khallagadi yam line atai ji loi la lai prove to yani yam line ko let's say sumaina ngarang gi angang du na pai bu do dumbbell ani do si kai do wa si axis da rotate tore amajina som chakre si jina som lai sumain to rotate tore ko abdi sumaina si axis da rotate tore अदुरगदी कैदौनी है मतमदा मागी ओमेगा जे नै खंगब्रा रोटेशन जी सी एक्सिस सिदा लेबा मतमदा omega की direction जी कायदे लेनी खंब्रा omega की direction जी मथक तले इतने अदुगा कई गुंबा rotation जी ना असी की direction जी लेगा दी omega की direction जी मखा ले इतने खंब्रा नो इसी जहाना खंगदब्रा खंगब्रो कुमो नो कुमदुदी कमाइन खंगदनो सरना
Sir, right hand thumb rule पाले
yes right hand thumb rule पाली ने बको if the fingers finger की direction जी the पोची rotate तो बता है omega की direction जी always normal or plane the plane of rotation that ko the omega si along the axis oi ni ba ana omega si up oi ni kai ma si direction si chala gadi and omega si down si direction chat adu si direction si chat pai si kai na matlab da si kai na si r ne this is the direction of r ne yanda right then v di kai na velocity tangential velocity this is the direction of the v ne adu di omega si omega si v suppose let's say omega cross r ji v tane ba omega cross r so nang na omega de v dom da nang finger do sweep to thara ko matam da nang gi thumb do v dom da point to rom ni omega cross r am ta tawre so na omega cross r to da v dom da point to dro se am ta yeng ne omega matak ta r lom da lao v da point to dro right hand to da ni ko left hand to ya de kan dai ta de
Right sir.
kumaktre noi loinama nasana tanda ajiki room du da noi nem phami room du tawjari yang nasana tanda tabra ta da baro du Lakshmi Sinthoi asterisk tawjari yang aba tabra tabra ba omega na matak
Right
ta
sir. Right sir.
na adidi v ki direction leitro thamja id cross product of vector natro khangbra ba sa haning ji kyan tabra ba tai ba ko Sinthoi nang keno to bro try to bro shit zon da kuma ki to ije tabra adum library da pham no orji dum yeng aduga atupa ga ji yeng ba r cross omega to ri yeng ta r cross omega adi b gi maning lom side ta dra amte yeng ne r cross omega to tabra v gi minus b lom ta bane r cross omega to ga di ta dra
Oh, right sir.
adugi ne ya dis ko adagi r cross b amu yeng ba r cross b to matam da omega direction da leibra r cross b di dai ko ai r di radially outward ne r cross b di omega direction da leiba awna si mamu ai di hyped si direction yu in the r cross b si ai ba si direction yu in ya de ba ko ade v cross r di yaro v cross r di makha leire omega na mathak leire aduna ma direction da inconsistent ore then v cross omega v ga omega ga to buda r gi direction leibra leite the v cross omega sim yadre then omega cross v omega cross v to matam r gi direction leibra leite v cross omega di r gi v cross omega si r gi direction lei ko chume v cross omega si r gi direction lei
voice call from Kailayantam Watson Geo.
just a second hello ito hello kai nam ta tadre kuram tadre one second ko ai kan to ge ko kuram pa ke ko how oh Okay, fine ko. Sorry, ngatan kino to reka. Sorry for the interruption. Important call over do gine ba ko. Kino ne hatare. Project ki matang do ba ko. Anyway. So, kaiba CG the direction that the eye, you know, you convince her ba. Nasana tauzer ying ba. R cross B to ba. R cross B. R then B lom sa pamatam da omega z matak tabne. R cross B omega tabne. R gi somnina. B ni somnina. R cross B to matak omega pangmne matak. Pangdrane. Pangru pang da bro. Kumaktre.
Pangisa.
Pangika.
Pangisa.
Adagi B cross omega tawagana R tabane. B dagi omega da B cross omega tawda R lom da lakane. B cross omega tawda. Ay di vector shift tawya ina si B je si da may pura som shift taw sa lawa. B cross omega taw R ta ne ba. Tabra. Lakshmi gyan tabra.
Hi, sir.
Prithviraj tabra. Sir haja.
Pangisa.
Ai ko. So adu regidi sir. Si ni jidi oidri ka yino. Atai jibudi my cross product si yadre have khange ba fail ore but si ni jidi yae ba. Du si ani jom ke do yadre na dimensionally inconsistent oi ba. Som gi dimension na kai no T inverse ne ba. Theta do dimension leite ba. Auna T inverse ne ba. Som da di kai no L by T or the L squared T inverse 1. Au di dimensionally inconsistent ore ba sa. Oire ko. Sumain ta uduna sidana kai no my dimension the left hand side ta R is distance ki dimension the L. Si the L by T ga the L T inverse 2 on L ga L T inverse 2 ga kamay mana to no. Sidana T inverse 1 ga L T inverse L squared T inverse 1 ga kamay man to no. Au na mana de on dimensionally inconsistent so mo oire au na sisu yadre gyan ta over sikita gyan ta over kan ko tri dio
Pangisa.
tai ko adu du gine aduna noina just in case in the future noina ngaro ko taraga di sise dum ningjing over ko then le. Now let's discuss some other formula. Angular momentum L is equal to R cross P. Now, podama Z sumaina kano the satpa matam da magi rotational motion satpa matam da this is the axis. R is kano R Z sumaina C ki direction ji da laidweni R ki direction ji ka. R ki C ki direction ji laidweni and P ji na kano P is in a linear tangential velocity ni aduna R cross P tawraga di mathakta laidiba L zina always mathakta gyan tai ko aisa R cross P sisi gyan ta ngamra
Ngami, sir.
ngami ko angular momentum has always the angular momentum gumba omega gumba and then torque gumba moise axis ki direction dum laiyo gyan tai ko aisa axis ki direction da dum nei kene axis to up oigera down oigera have the magi keno imaka pole rotation imaka pole but axis ki direction da ni so R cross P ne si da P cross R to yaro na P cross R to makha sakra ne ba di yaro on R cross P ga do adain to duna to tau ki direction ji kaino R cross F kai no R na si le and force ti kaino som side to force P ren kala je the R cross F har mathak ta tau som nei do na happy dum manabani ko si sir na physical keno di tak ti am tak ning ne du palitre noi test ala ko da tak to mungai ko na tragan noi ne ga la ke har ga di koi test to center du da tak pe ai nong ko nong matang physical class to thuk pe ai rotational motion je ko it's di kai no di yamna important oi ba si gi au da gi atopa kai lei adu dum khang jalo ko da gi di atopa formula da totally different formula da kai le ya matam L je momentum is linear angular momentum ni ko L je linear momentum na te ko so angular momentum is angular mass the moment of inertia angular velocity na omega so I omega so high and torque is the rotational force ne ba the force ki analog ne tare ko rotational analog of force ne force the mass into acceleration una rotational mass the moment of inertia acceleration the alpha so I alpha yan da right sumai lai du ne ba ngau bra jikida just compare to over P vector is equal to MB vector to compare to over sidana kai ka compare to deba F vector is equal to MA vector compare to over Bro, Kenta bro.
Hi, sir.
Sir.
Taiko.
Sorry,
So
sir.
aduni. Adumaina laitine ko. Aduga atopana atopa ma kaino alpha dudi the d omega by dt ni ko adudi thidongna kaino yam kana kaino yaudre. Alpha A is equal to alpha cross. CD B is equal to omega cross R. Sida nang differentiate or dv by dt d A ni d omega by dt d alpha ni ko R do constant or kanda. Yan dai ko adun alpha cross R sumana har si ai. So sigi formula me am sine fazana clear oina laigadabni mind ko. Aduga mathangda kai tawzige habda kaino tawsi law of conservation of angular momentum tawsi. Prithviraj law of conservation of linear momentum na kaya hai?
Sir, M1 B1 equal to M2 B2.
No. This is the application. The collision they apply to law of conservation of linear momentum. Adu law of conservation of linear momentum not there. Law of conservation of linear momentum ki application never. Adu collision they apply to one never ko. But law of conservation of linear momentum is kain over. Lakshmi try to. Lakshmi tabra.
Sorry, sir.
Law of conservation of linear momentum khang bra.
Sir.
Khang adi haro. Yam ten haro. Nangi khangjabi da. Magi full sentence adu da hai to nang na khangjabi mong da haro. According to your understanding. Yes, Lakshmi.
Closed system amada mass laiba wasak amana chatpa kanda magi velocity
Okay.
ga momentum do conserve kari.
Okay. Closed system hai di kaino.
External force laitaba.
Okay, yeah. Very good, Lakshmi. Ka. Asterisk try to.
Sir, net external force later on the system of particles so constant we never
System of particles ki kari no constant hoy tije.
both my momentum low.
Okay, yeah. Very good. So if there is no net external force, external force, in absence of net external force, the total linear momentum of a body ama katang oragana of a body natragana system of particles oraga suka. Adu dugi to the total linear momentum of a body or a system of particles remains constant have never. Karam kanda if the net external force is zero. And net external force ambo pangdragadi momentum ji kaine change masamatan tawzaroiba momentum hongo swade masamatan change tawzaroiba. I total momentum of the system the manung the individual amaga thongaina by change to the but net momentum do the constant or laineba. A boom was pokai nakanam the katang pai thueba. Nakanam the katang pai thugadi momentum do as it pokaidring in the zero or manina. Pokaya can the C particle gauge momentum yaugreba. Oh, this home the zuka pai thokaneba. I do my vector nina cancel out to zero targetum never. Oh, nakadoni have that in all possible directions. Pokaya can a bomb. Then because some of the kayam pai to enclose a mass, some the pai to mass on a yam dragati, some the velocity the in a yamakaneva. Hide the resultant momentum though mass in the velocity, some the sally mass in the velocity cancel out to zero target of never. Anna kainamatum the external force out the internal force na momentum change to ngam devaka. Adumaina todana law of conservation of angular momentum. Jina kaino have the in absence of net external torque ama leitragadi body amagi angular momentum song hoiba external torque leiragadi hongje adu khangde but leitragadi song hoiba can dai ga and in absence of net external torque the total angular momentum of a body or system of particles remains constant haidiba chamane can dai ga force mo the torque haidiba linear momentum mo the angular momentum haidiba can da over sigida
Hối
Down
sir.
below.
Oh, sir.
So in absence of net external torque, the total angular momentum of a body or a system of particles remains constant. And that guy, see, aduki fazaba kaino amani ko sigisa. Law of conservation of angular momentum. Aduki matik fazai ko. Mazi yam fazai ainwidang sisu video ma yengan ge chapkadra chapoy drive the kangdre. But I just want to show it ka. Siko. Kailangan okay, fine. So resume. Okay, resume to ya this again. Resume. Now, no sir na ne video ma share to is no you talk pre ko. Haro do. Talk pra.
The sum total of the
Sorry, sir.
angular
Sorry.
the angular. No, I'm not going to check that. No idea. Today we're going to talk about angular momentum. Any spinning object, such as the Earth here, which is rotating, has an angular momentum, which has the symbol L. The angular momentum is a vector quantity, so Brady put an arrow over the top just to indicate that it's a pointy thing. The angular momentum is pointing up, in this case, from the South Pole to the North Pole as it's rotating that way round. That's the direction of it. The magnitude depends upon the mass of the Earth times the radius of the Earth squared. And there's a numerical factor, which I can't remember, but it's a first year calculation to do it. You don't want to know about the numbers, but it's proportional to that. And it keeps on going unless there's some force of friction on the side, which I'm providing with this blue tack by getting it either to slow down like that or to speed up. And it's this sideways, whoops, it moved. Yeah. Can you do? This is any rotating object, and we're going to illustrate it further by looking at bicycle wheels. One of the reasons you don't fall off a bike, or I hope you don't fall off a bike, is when you're pedaling it, there is angular momentum associated with the rotation of the wheel. George? This is a bicycle wheel, which, before we start, we'll leave it stationary and see what happens if I dangle it from a string. I'll dangle it from this side, I think. And, of course, it wants to fall out of it. But if I keep it like that, the string will hold it vertical. It doesn't want to remain like that at all. But if my beautiful lady assistant, George, would like to get that spinning, I'm not allowed to do dangerous work. George. Thank you. Okay. So now I'm going to hold it by putting this string over here and dangling it down. And you see, if I left it without the spinning, it would want to stay in the horizontal plane. But now, actually, the angular momentum wants to keep in the same direction. Unfortunately, it tries to tip over. When it tries to tip over, it goes around in a circle. But it doesn't want to fall off. This is a very, very stable arrangement. Well, if you're riding a bike and the bike is going along and you suddenly tip over, it doesn't really want to carry on in the same direction. It would prefer to revert back to the vertical. You design the bike wheels and the front forks in such a way that it leads you back into the right direction. So the angular momentum tries to remain constant going down the axis, and tipping it over, well, it doesn't like being budged away from the direction it's moving. So the faster you go, the more stable you are. If you're trying to do it standing still or completely stationary, it is quite difficult to balance on a bicycle and completely impossible on a monocycle. Angular momentum is conserved unless there's some friction which will get things to slow down. So if you get an atom in a particular state, it will stay in that state with a particular value of angular momentum. Or if you have a bicycle wheel that's going round and there's no friction, it will carry on rotating forever. Or if the Earth spins round, if there's no friction, the Earth will keep spinning round forever. There's going to be a little bit of friction because of the air molecules rubbing against the Earth or the water rubbing against the shores, and there will be some friction that tries to slow it down. But that apart, it will keep going, well, at least for my lifetime, which is all that matters as far as I'm concerned. I'm sitting on a chair which just rotates very easily, so I am actually a spinning object at the moment, and I don't want to be a spinning object. I want to make sure that my angular momentum is zero, and then George is going to spin the thing up so much that there's going to be a huge amount of angular momentum. So I start again, and there's angular momentum this way, but I'm not going to worry about. There's no angular momentum about this axis vertically. But if I switch this way, this is now rotating around, and I had to go the other way in order to keep the total angular momentum constant. And now I've turned it back, and I'm going back the other way, and I can keep. I think it's fun. Keep turning it over, and the total angular momentum remains fixed. And turning it over again, I come backwards. So the sum total of my angular momentum about this axis and the wheel's angular momentum is the same, apart from the fact that there's a bit of friction. A bit of friction will slow the wheel down. But even when I'm at this stage, I can turn it the other way, and the angular momentum about the vertical axis is constant. All right. Now I'm going to show you that the angular momentum also depends on how I distribute my mass. Now, my mass is distributed in my self-like body uniformly, I wish. And I'm going to illustrate the effect of distributing mass by carrying a kilogram weight on either end. So, George, would you like to rotate me around with my arms out? And it's the moment of inertia depends on the distribution of mass and how far it is away from the center of axis. And if I bring these masses in, the angular velocity will increase dramatically, and I'm going to be sick. And then, can you spin me? Oh dear. What is a professor when he spins? The sum total of the angular momentum, You okay? No, I'm not okay. I have no idea. So what happened there was, after I was sick, start again. And what happened there was that as I put these weights out, just like an ice skater who's spinning, putting her arms out, you rotate around, and with the arms out, you have a lot of angular momentum associated with these masses far from your body, which is part of your moment of inertia. Now, as you bring your arms in, as I brought these masses in, so your angular momentum remains constant. The moment of inertia goes down because you brought them in closer, and you speed up, and you really get giddy. I don't know how those ice dancers do it, because they somehow lean their head back and don't get giddy, and they go round like that forever. But oh dear, I'm not really feeling myself.
Okay, fine. So that's it. Dina. Okay. Hazikidu kena tahu bra? Gian tahu bra dong?
I realized underwater. I just didn't realize I was there.
Okay, fine. So aduna law of conservation of angular momentum. Yamna fazaba law amne bako. Yamti ne important hoy ba ta. No ji ba na khangadam ne. Aduna law of conservation of angular momentum. See, kado we have no even gravity does sizinarkani ko. Am sinarkani ba. Ngasagi malasum to example ma'am the kado we have the ngasagi bicycle wheel do. No sumaina dangle to ya laga thamba sigi kano chida ko. Kama hai sige any circular object labra. For example, CC bicycle wheel name kala si the trying to ya la thamme. Si the to ya laga. Maji ya la thamma to sumaina lining de ko. My the center of mass na ID kitang unbalanced kitang with the sumaino in a tarak no hunani, but maji spin to ring matam the sumaina dum lay ko. No young slow cycle race ka to slow cycle race the kedawi. Calm lady go cycle to reva. I do calm the vida Tauraga dickedawi 2 deva. Cycle can the Taurigation to 2 deva. Yandaigo can the Tori see a position to the never. ana ke do we have matam wheel do na spin do matam da wheel do gi angular momentum chocolate auna angular momentum ji ke do we have matam da change do matam torque change ba adugi necessary torque to koina pi draga di angular momentum da change do yaroi ba aduna adu angular momentum do change do no hona bi am wani ba ko atugi ne ba aduna ke do we have the spin to object ama heta koina phalam pha ha bi magi angular momentum do adu da depend to ba adugi angular momentum di am chaw ga di heta pha ba ngam moi ba yan dai ta de tai ko ta bra ta da bra
Hi, sir.
tai ko adain to na
Right,
adagi muka yes angular momentum formula ji kaino L is equal to R cross P hai ba auna aina P du magi tensor velocity do ke do aina R ji pixel la ga di isa manak ta naksal la ga di ke do ni ya matam da P du chokala kani ke angular momentum ji by default masa mathan change to ya de ona R pixel la di P chokala kani ona aroi bida kanna ungtala kani ba adu R ji chokala kana P picture kani ama chokala ama picture kadam ne ba ko animak habidi kaino habda ama chokala ne gyan tare bata driven nice kai chakre ठीक है angular momentum है बिजी कहीं ना L है R cross P ने R ना चौकला दी P पिक्चर कनी R ना P अगर ना P चौकला कनी नत्र अगर I omega दा हर चीज़ आएगा नंग ना distance to massing do exist नक्शा लग पाए moment of inertia पिला कर दोने बा moment of inertia I जी पिला गरी omega चौकला कनी बा कन्न उंगा कनी बा my angular velocity दो नंग ना I जी चौकला बा mass लाभ थो बा अदुदी omega पिक्चर कनी बा तब ना उंगा कनी बा अदुना ने बा I scatter के काना मुका I scatter के काना मुका कई दो भी है बा मोइना kani ice gymnast habra ko moi kangbuna performance utpam matam moi body gi pra spin dawraga ko pra spin dawraga moi lepam dai da mukut kai sumainga sangna ga mukut kai tingthoga lepi dana ko so adu du kai do ya da moi just phajabai katang na teba physics ne ba du mukut tingtho kanda tapthara kane ba gyan dai kai je moi mass se spread out tor kanda I chokala kani I chokala di omega picture kane ba or R chokala di P picture kane ba tangential kyan dai ko momentum tak long ung ba adain to lei adagi di adu leire ko ung bagi nga sai gi nei okay fine atopa example ma'am su leire aduna noina adin noina adagi next chapter da kai tamakani amatam da noi Kepler law ga tamako matam da planets ga the line joining between the sun and the center of the planet center of the sun and center of planet ke sweeps equal areas in equal intervals of time हाइबदी लापगदी खितंग चटकनी नअगना मयाम चटकनी के एरिया दो मानना बाना हाइदो नक्सल लगदी के दो या मतमदा नक्सल लगदी पोची एंगुलर मोमेंटम दो कॉन्स्टेंट होइने मासी r पिलबनी ना p जी चौखलकनेबा और I पिलबनी नक्सलदी I p दी ओमेगा चौखलकनेबा अदु लापथोगदी के दो या r जी चावबनी ना p तपकनी खितंग चटकनेबा को अदगी लापथोगदी I चावरे अदुना ओमेगा तपकनेबा को सो सुमाइना लेइबा ज्ञान ताबरसन हाइनिंग जे taiko aduna angular momentum conservation of angular momentum is very important aduga angular momentum ki si conservation law si khang da sunga ya de hati law of conservation of linear momentum yam important oi bido sumai to law of conservation of angular momentum is also very important me am lo yari ba asterisk yari ko Prithviras yari ba
Hi, sir.
okay fine. Now let's try to solve some questions and then moment of inertia formula as it taxira. Question ka solve tau ziko. Dun pani na traga disum theory nga ta tau le bi nungai te ba. Ai bo board o shale theory sum tau le ka. Question ka solve tau. Angular velocity and its relation with linear velocity. Okay, so asidi no ikanga ni ko r ga omega ga. So Hyro Prithviras Hyro, what is the relationship between r omega and v?
B is equal to omega into R.
Omega cross R hayo ko into hayo
Cross R.
cross product ne into do dinang dot oidera cross oidera hayo question namaga kumda wat so omega cross R adu dinang na sisi kaita ni kangbra 5 into something je 3 ta ge haga di 5 into kaita ne 3 by 5 3 by 5 yaw da bra sorry I did dot product wa kan kali je one shit sorry so adu din nai ngasai matrix ki mong da thammo adu ko lo adu ko dum tajara ni si ngamgadra question number 15 ja
ngamani ja
Lakshmi ga ngamgadra Lakshmi ta hudre
sir.
Ngamni buka. Okay, fine. What's here this sir? What's it? Talk and angular momentum. Find the talk about the origin when they talk of this x on a particle whose position vector is this. Question number 16 jeng am gadre. Talk put hoy. Am gadra. Am gadra. Haro. Kumak tray. Question number 16 am gadra Lakshmi. Prithviraj Pochira am gadra. Ta tre.
Sir.
Am gani buka. Prithviraj am dro. 16 ja.
Sir, CJ talk equal to R cross F token, sir.
Yes, talk is equal to R cross F to dini.
Oh, yeah, sir.
Yeah, ni ka. So F sina 3 J cap lere, R sina 2 K cap lere. Ka, na cross product law. So J cross K di kay na. Nothing ante R cross F na tra. K cross J di kay na. Minus I. Ako na minus 6 I cap taan. Yari ko? Option number C. Matang da, question number 17, the moment of the force. Moment of the force hai di talk ni ko. Talk si atopa maming moment of force hai ba. Or rotational analog of force ka jo hai ba. Force ang pyramid position vector puto ke dinang isi ki position ani di pyramid aduna si dari delta r puto ni duga f to delta r tawan. Si singam gadra. Question number 17 ngam gadra ngam ito sir hanaro.
Ngamni sir.
Amnesia.
Sir.
Okay, question number 18 ding ngam gadra yung sasat yung ko. Question number 18 19 yung aduga noi di yawa question le ga su sir da thazalo. Question number 18 19 ngam gadra sasat yung
Sir, 19 talks.
question number 19 daw sa ka. Okay, daw stars. Right, so let's solve it. A mass M moves in a circle. A mass M moves in a circle on a smooth horizontal plane with velocity v0 at a radius r0. The mass is attached to a spring which passes through a smooth hole in the plane as shown. The tension in the string is increased gradually and finally moves M. Finally, M moves in a circle of radius r0 by 2. The final value of the kinetic energy is. Okay, fine. So, kinetic energy is rotational kinetic energy sulai and translational kinetic energy sulai. So, rotational kinetic energy ki formula Haro Lakshmi Khangbra. Khangdabra.
Half I alpha square.
Half I omega square na tro.
Omega square.
Some side ko si kay half I omega square neba. Som na kay no kinetic energy si half m b square neba ko. So it's my negative. Aduni so those stories matang stories ka. Okay. Okay, fine. So now, the tension in the string is increased gradually, and finally, M moves in a circle of radius r0 by 2 and a half neighbor. Adu ergadi ngasai r0 to ungambadu r0 by 2 the unkaleva. The final value of the kinetic energy is and a half neighbor. Now, adu ergadi sigisi question sida magi demands kaino man. So with velocity v0 and the radius r0. So initial kinetic energy is kaino. Okay, fine. Initial kinetic energy C half m v0 square plus half harga magi ka moment of inertia. The final value of kinetic energy harga. Okay, so magi moment of inertia ga I harge and omega square, omega naught square ita. I is with the mr square with the neva. So I see the my measure aduga omega naught the kind of the b is equal to omega cross r natra. Do not. Okay, don't you have that? Sir, na see questions you answer you sir gyan tare, but correct explain toning is easy cut. So v na kedoni have matam sidagi mr square kind of I gi motono na sidagi the mr square kai tor seba ka yeng seba kedogi have ana kai leini have matam sidagi the mr square r not square has okay small r not sinare ka kam kai de omega gi mota v square by c is 90 degree sin 90 degree di 1 in adum square b square by r square has yare r square cancel chala kanda initial m b not square le half plus half the 1 in the car. So initial Contd energy in season. Now kaidoni amatam the final Contd energy say azik kaidawi have matam the magi kahene. The mass is attached to a string which passes through a smooth hole in the plane. Now the tension in the string is gradually increased, and finally m moves in a circle of radius r0 by 2 now. The final value of the kinetic energy is an so kaigumba sigisina kaidoba r0 by 2 the lakumatam da mazi kaidorakani have matam da sigi question sa conservation of angular momentum da based over question oigadane bako aduna kuina L is equal to okay L is equal to R cross P and later. Okay, fine. So aduna kaidorkani tension in this string is increased and finally moves in a circle of radius r0 by 2. Adu is the r0 by 2 lakota agadi magi ngasai L dash r0 by 2 la neva. Adu is in 2 times of P la neva ka. Adu ngasai gi di dum lai gede. Yanda guys. Auna magi angular momentum C L the puthosu yabudi ai kinetic energy se khina momentum p square by 2m do adain to na L square by 2y and to share but adudi amuka na si chana dire kitan complex warni ko initial kinetic energy C lere aduga total kinetic energy se nakshal lakpa matam da kaidorakani have da magi keno di yankhalakani ko omega yankhalakani yes Naxala the omega si yankalakani can also yankalakani, but moment of inertia on picturakani buka. I is picturakani compensator ni L the constant with any. Auna half mb square half mb square is the came the change story, but Nasagi translational kinetic energy the change store kani. So translational kinetic energy combined change store kani have the name important or is na b square. The final value of the kinetic energy is an have a car. So external force later energy internal internal mv squared kano tabra option number C tabra the final value of the kinetic energies
C tayo sir.
Okay C dum tayo ko then adu ergadi kano tawde have neba kayani magi si kaidoba change laite have neba sarna ko so to is dagi can change laite have neba aduna kari okay fine just 1 second
Sir, A oina taram. Ay ubada so oina ura.
Okay ka kuina kai gi na matam angular momentum di conserve for ni dana ka aduna adudagi koina ngasai kaidoba haibada kinetic energy se adudu koina puthokadane ko aduna angular momentum se conserve oibasina adada kinetic energy kaidoba puthokpa ko. So final kinetic energy to in terms of initial kinetic energy the puthokadamne ko aduna di koina kaidoba yai haibada initial kinetic energy puthoe ko sumain tawdabida koina sidai sisu dam leijasano ko topa amka tawge no worries. Let's see. Sumain tawring seba ko sida aina kedo ya pochi nakshala amnina pochi hiena unkala ni yang unkala ni ko ana yang unkala kunina kedo kani habada angular momentum ni kisumta change tawba leite ko. There is no change in angular momentum matter. 1 second. Yeah. Okay. Yeah. So adu bitaragadi aina kedoni hamatamda L I is equal to LF. LID can have the R cross P ni ka. So R cross P di can M D naught. R naught is equal to R naught by 2. A capital R naught sin adre ka small R naught sin adre kam kai de M harga B R cross M B cross M B has ya. Adu leno perpendicular amina sigi vector ke sam to pandus yare ko. R naught cancel mm cancel credit V vector V is equal to 2 times of B naught R. Can tabra sisa tai ko tabra tabra bro tai
sir.
tai aduna do we have the infinity L is equal to R cross P ne ko or R cross MB has aduna define kai do ni matam the kinetic energy initial kinetic energy is kai na da half mb square ne ko aduga the final value of the kinetic energy is oh I don't have to find out this, I have to find out only the initial and final kinetic energy kf is equal to half m and v I'll just remove this vector direction half mv square half mv square. Now half mv 2 times of v naught whole square, which is equal to 2m v naught square. So 2m v naught square is option number A. Option number A sumain ta 2m v naught square ka. Gyan tabra si se final kinetic energy se.
Aye, sir.
Tai ka. So sumaina so akwina kedo we have the CC conservation of angular momentum dagi pan manewa. Yare ka. Auda nuina hangbe sir kainodi nuin kedoba again ngasai akwina sir I omega synergy kaina I omega synergy aiba but I omega ga R cross P ga si chap maneiba I omega gi data su deba koin omega gi data leite I gi data leite ba but kainogi data di leiba R su lei P su lei R cross P sinam nen phare ba ko adu duma tosalo daidi kedo we have matam da again I omega later nina koina ngasai gi kaino do kinetic energy da half I omega square do adu puthuoroi haitare ko auna half mb square katang puthuoni si final ni initial budi half mb naught square ne ba ko auna kai gumba moina in terms of kaino ka har magadi kf is equal to how many times of ki ga har magadi kai tani si khangbra 4 times abra 4 times of ki ai tadro kf se Ngaubra.
Ngawe, sir.
Ngawe.
Tayo, sir.
Kay ngawe no ne. Si jibu si 4 times of half MB no square hayatro. Si the ki
Dito
ay
ang sakto daw, sir.
Tai ka. Okay, fine. So question the mamang sumay hang na matung sumay hang asu yai ba ko. Aduna adudu section gadam ne ba. Gyan tai ta te. Tai ko. Yar ba? Okay, tare ba ko. Okay, fine. So let's move on to the next question. Question number 20. When a mass is rotating in a plane about a fixed its angular momentum is directed along. See, hero, sige, my angular momentum is a direction. Lay hero. So, hero. Sir, nang sa kaya hagi angular momentum oigera kaya ba? Mathakta adi mathak oigera makha my axis ki direction the lay perpendicular to the plane of the rotation I get the ko adum mathakta lay L zu omega su talk su ai ta loi mathakta lay gyan dai ka ja omega zu mathak or makha ko ai shi ji kamai to muthala me omega ai den okay fine yeah. So aduna is the line perpendicular to the plane of rotation. Yes, chumbai. The line making alpha C R option B R radius R D Z R ko. So option kay tarni si option A tarni ko. Loy loy gyan taobra noy humak tabra noy mari mak tabra.
Now,
Ngawe, sir.
Great. Then the question number 21. A small mass attached to a spring rotates on a frictionless tabletop as shown. If the tension in the string is increased by pulling the string, causing the radius of the circular motion to decrease by a factor of 2, the kinetic energy of the mass will increase by 4. Natra, Hajikta sir na give the increase by a factor of 4. Direct option number D tabrion. She's 2011 D tabrion. Tabra. Taiko. So, see never question revision. No na hanjan taro pay kana ba pay kada nang si question di bio code pay type ko loidra. Tak law na. So holo loidam ni. Haidi kayumba suppose si same question din nang haying any test real NEET exam oigera any mock test oigera adu hanging kale si question je. Nang code kidra ba call roy tak adum code kredam ne ba. Adu potu ne ba ina pam mi je. Aduna adu pangge ha ne revision je hanjan taw de yaro revision amuk ani ra ohna taw ne yaro ko. Aduna first phase ki revision jema fadan tawro second phase test ki second phase lakani adu pan tawro third phase pan tawro aduga exam hadi ke dawni have the marak no revision taw de yaro adu dai no de ke dawro kani have da question je ubaga answer kumbaga ma ko stage am yor kani most of the question kudi mangna traga zuka most of the question now question number 22 ko 23 ke paro 24 22 23 24 paro karam ngamoi loi ngamni hargadi skip tawzi ngamoi da yawade har 22 23 24 par saja haro du question number 22 is
Sir,
haro
22 je sir D tagadra.
22 d ta ga ka
B sir B je.
B ta ga ka r ga taw ga si dot product log di perpendicular wa ni na 0 ta ni f ka taw ga su
Origin.
0 ta ni si chumme
Oh sir.
aduga atai di si mi chumme atai di r ga taw ga si greater than 0 hai f ka taw ga less than 0 hai asi ka su leite ko greater than 0 less than 0 hai dagi si r ga taw ga 0 tai f ka taw ga 0 ta de 0 ta de kai no di moi loina ma mutually perpendicular ngata na tro loi mutually perpendicular ni na dot product law di loi 0 ta roi tro
0
Lakshmi gyan tabra.
Tayo, sir.
Asterisk tabra.
Tayo, sir.
Okay. Question number 23, 24, 25 yang adu. 23, 24, 25 lowing amni hadi harong amoy dio di harong.
Sir, si cross product lo itaw din natro.
Sir, question part 3, question yung a particular mass moves in the
24, 25 24, 25 sir.
Yes, cross product ni across F to ni. What is the talk on the of the force F is equal to this? Yes, C so adum across F to ni. Cross product to ni. No, adum cross product to di hay binatro no yung ma. IJK to may makada coefficient ga iraga cross to do.
Any sir.
Tayo, sir.
Okay, so question number 23 is a particle of mass m moves in the xy plane with a velocity v along the straight line AB. If the angular momentum of the particle with respect to origin is LA, then what is when it is at A, and LB when it is at B, then LA is equal to LB. Relation between LA and LB depends upon the slope. Blah blah blah. See question is gyan tabra hai gadra. Haro. So haro.
Sir, explain betul.
Explain to bioba. Okay. A particle of mass m moves in the xy plane with a velocity v along the straight line AB. If the angular momentum of the particle with respect to origin O is LA when it is at A, which is the position vector. And mass Z, Sigi, Ani, Sigi, Sisina, Magi velocity direction ni, and then angular momentum, Sisina R direction ni, Sisina P, velocity R P direction ni. Ani is the perpendicular or any, so R cross P has somewhere at the R C direction, any angular LA. Adu chap manana zik keda we have the sumain tauraga sidong lani si sinong RB and say particle sida dum chatle si sina kaino si sina P PB hata say giduna P ne bu ko adu ragati magi R cross B to matam na muka somdong lani and like tangi kaino LA ga LB ko manani. Relationship between LA and LB depends upon the slope of the line AB. LA is greater than LB and LA is less than LB. So, okay, fine. Now, kaya we have matam da munna kala yang obuka. Kaya no matam da LA ga LB kasi mana badi yaroy. Kaya we mana badi yaroy duna matam LA is kaya no LA is RA cross P ne. LB is na kaya no RA cross RB cross B ne. Yes, kaya no. RB cross P ne. Ganda right? Now, P is the particle is moving in straight line, and the particle has mass m, and it is moving with constant velocity v. So my P is constant. RA ga RB ga mana position vector ni the mana deva. Position vector and the mana dragati combined to LA ga LB ga mana to LA ga LB ga mana ga mana roe. The relationship between LA and LB depends upon the slope of the line AB. The slope of the line AB that depends on the tasingna tawdi tawde kayino have the LA na chaw LB na chawni kai you distance RB ni chaw pani na ko LB na chaw de option number C ta bram tiyo tiyo me okay so option number C ta da bra ta de
Tade, sir.
ta de ko okay dur ga di ko ji kai so yeng si ko CC budi kem ta kai de ba okay so CC sa do ke ko ina RAP sin theta am le ni RB sin theta am le ni ko okay yam phasai so CC ina kai haibi ya P harga RA sin theta haibi ya and CC na P harga RB sin theta haibi ya ko awna noi sir na haibi question and practice to haido ai na habda khangye na leithok ya de ko sir hajik soi gi toidio awna CC sumain to matam da di practice to kan da di last ti kai wera me matam da let's see RA sin theta ga RB sin theta ga di amuka chap manarane ba kai no matam da ne origin da gi ngasai gi magi say origin is just point amne any line am le whatever ana C gi angle ko ganda right so C RA gi direction ne ba C na P gi direction ni na ko sa C na RA gi direction ne ba let's say C na kai na let's say this is RA gi direction and let's say this is RB gi direction ne ba P di dum asidum like ni ko this is P gi direction this is P gi direction now angle between RA and AC is theta ne C is theta ne now theta ni mana de mana bra mande ko si theta le na si dong theta le ne si theta le si dong theta le ne but now sin theta di ke wini bra sin theta di C gi C je do moi ne see no matter what this is RA sin theta and this is RB sin theta natra sin theta is again no abdi RA is let's say this is RA vector natra and this is this is RB vector natra audi C common line je CG kai no have CG triangle C yeng the RA sin theta natra C RB the yeng the RB sin theta so C dum ta dra auna sir na ngasai RA ga RB gi mana de budi hai gi ba but P do thamora ga in C u hodre ba ko C sin theta sin phi hai ja sin theta 1 sin theta 2 hai ge ba ko auna kai oini ya matam da RA sin theta 1 is equal to RB sin theta 2 hai ta shi ni mana ye ba shi ni mana ba na LA ga LB ga mana ni ba on option number A ta ne ba option number A ta bra tai ko gyan ta hodra ba ma le ngang ge gyan ta hodra ba no ai
Tade, sir.
Aisha.
sing ko sing kita di tai ko ne kai ni te yarabo singabo gyan ta hobro sing ki
Oh, sir.
RB sin theta du ta de ne ba C gi CC gyan ta right ja CC aduga CC kai ga sumana ne ha da RA sin theta ga sumana ne C triangle ji da dum yengo ba na sana da gyan ta re ko auna akoina manadaba manjaraga su LA ga kedoba LA ga LB ga sai sai mana dina high green ne kai no P mana jo RB man dina but sin theta 1 sin theta 2 to kon tam RA sin theta 1 ga RB sin theta 2 ga mana le me ko aduna LA ga LB ga mana ba so C question ji ju kai dong ne ma tam no na khangjela ga di pe ka nga di dum dai khot ya ni ko practice wala ga di so be chance wang dra sa adu madu khanga dam ne apajana gyan tai ta de
Tade, sir.
abro tai ko okay So 24 tawro 25 na san tawzaro 2060 particular ma going to the she's the higher question number 26 yeah question number 26 ngam yung ngam gadyo question number 6 inside can tell that question number 6 ngam gadra okay 1991 a particular mass m is equal to 5 is moving with uniform speed v in the x or y plane along the line this the magnitude of the angular momentum of the particle about the origin is an havoc. So angular momentum puto kaya gadi kaino r cross p ne ba. So r di kamay puto kani ha matam da nang na y equal to x plus 4 dagi puto ni line dagi my perpendicular distance to p di kamay puto kani have the m ga p ga the 15 root 2 layer p di ko mass into velocity 15 root 2 aduga my r di noina kai puto kani have the r to the y equal to x plus 5 the distance of a line from a point to adu khang the r ko adu du khang bra sigi question je ga dai ro sa dai na ro ai ro ko okay fine sir set okay ko de angular momentum L is equal to r cross p. Now PD I'm like PD no MB. Yes, along the line. Now along the line y is equal to x plus 4 have so the r puto kya let's say x na 0 with the y is 4 and y na 0 with the x is minus 4 sigi line din now sigi line se cc origin de kyam lap ke have the name na puto ko this lines can that guys so kamay puto kani sigi sida kay na the x minus y plus 4 is equal to 0 ne sigi line the equation ko the this distance d put and origin di kino 0 0 ne origin and sigi magi sigi distance of a point sorry distance of a line from the origin the formula do noi khangbra hafe khangdabra kayuni khangbra do kayuni amatam da root over my distance ki my formula do 1 suppose let's say ax plus by plus c is equal to 0 matam the magi distance formula do kayo given have the my distance formula do kayo root over a square plus b square she's the derived to the avco in the derived t has it toning day do you want to aduna combine to sige have the sige section formula pan dia do ni ko CG coordinates ay khangani C coordinates ju khangani aduga CG point CG keno khangani aduga this the point ani gi makta leba distance dem ko distance formula pan ya ne ba first section formula han palani aduga distance formula pala gong tarakadini ba adu du dem yam sangmal la do ba ina adugi derivation yam tawning da ba ji ko kasu yam du do di na ta ba but adu tawning de ba adugi ne so what is the formula for distance of a point on the line have to let's see okay ID derive to the formula to recall to drive so what is the So I don't get anything, any good result. Vera just a second. Okay, yes. 1 second. Aduna akwina distance formula si kai lei hai matamda sigi line jiga kaidoba origin gai distance formula se d je kai oini hai matamda c by root over a square plus b square na lei ba ko si je from the origin akoi gi si gi sida di r si kai oini distance da timing jam sana de aduna kaidoni have the c do kai na koi gi di si gi c je 4 na tra mani ko. So 4 by root over kaino 1 square plus minus 1 whole square. Audi kai tarni 4 by root 2 tarba. So 4 by root 2 is r neva. Adi the L kai tarni kaidoba r cross p natra. Is it 0? Kai you know the my distance r leka. Yes, okay, fine. Nothing 0 nothing perpendicular with okay, fine. So r cross p tareka. Ani ji si r ji kena magi position vector ji sigi direction ji leitune ba position vector ji p na asigi direction ji le ne on perpendicular arm ni na sin 90 degree ni 1 toraga queen r cross p ji 4 by root 2 into 15 by root 2 to 15 into 40 60 units tabre answer do amte tabra 60 units tabra
sir.
Okay, fine. So yare ka tiger stress. Okay, fine. So ngasi gidi sipau torga loshalazi ka ngasi gidi. Thank you for the class. Lakshmi, Asterisk, ka, Pitviras.
Sir.
Okay.
Good night, sir.
Good night.